Okay, so hello everyone, welcome to क्यू फिजिक्स एकेडमी। आज के जो लेक्चर्स है, इस आज का लेक्चर्स में हम लोग इलेक्ट्रोस्टैटिक्स एंड मैग्नेटोस्टैटिक्स का जो लेक्चर नंबर 14 से लेक्चर नंबर 14, उस लेक्चर नंबर 14 को हम लोग कंटिन्यू करने वाले। ठीक है, तो इस लेक्चर नंबर 14 में we will discuss the electrostatics energy, the work done when a charge is moving from a point to another point, that is called basically potential energy, or work done for the displacement of this charge. So we have to calculate this part is here in details also. Okay, and another things also here covered the calculations of electrostatics energy for a system of charge. आप लोग मान लीजिए आपके पास एक ट्रायंगल शेप है, उस ट्रायंगल शेप का हर एक कॉर्नर में डिफरेंट मैग्नीट्यूड का चार्ज है, तो उसके लिए तुमको सेंटर में इलेक्ट्रोस्टैटिक्स एनर्जी कैलकुलेशंस करना है। तो इस तरह का प्रॉब्लम्स हम लोग कैसे डील करना है, तो इस लेक्चर्स में हम लोग उसी के ऊपर बेसिकली थोड़ा बहुत डिस्कशन करने वाले। ठीक है, तो ये वाला लेक्चर्स CSIR नेट, IIT जैम और TIFR, JEST और गेट एग्ज़ाम के लिए बहुत इंपॉर्टेंट होगा। तो इस लेक्चर्स में हम लोग सारे PIQs भी डिस्कस करने वाले। जो PIQs है मतलब प्रॉब्लम बेस्ड हम लोग डिस्कशंस करेंगे इस लेक्चर्स के थ्रू। ठीक है, so basically we start the work done to move a point charge we have to discuss here. Okay, so okay, energy, okay, the energy, the work done to move a point charge. Okay, to move a point charge. So basically, what's the expressions of work done? We already know the expressions of work done is actually Q into V. Okay, where Q is the charge, which is point charge, and V is the potential. At the point where we move this charge. So basically, if I take a this is the point, that is r equals to infinity. At that point, this V of A, at that point potential is 0, and that is r equals to B point, and at that point potential VB equals to B. So here we want to take a finite charge from infinity to a finite point B, and then for this movement of this charge from point A to point B, will store in terms of we did some work done. Okay, work done, and that work done is stored in terms of actually potential energy. So this potential energy is equals to this potential energy is it's nothing but the work done. Okay, so here the potential energy nothing but the work done. You have to remember this. Okay. So uh, so here so here uh, if we want to move a point charge from a finite point to another finite point, then what happened actually? Okay. So what happened actually? So if we want to move a point charge from point A to B, okay, let us take so the point R equals to A, so the point R equals to B, okay, and here charge is moved from point A to point B, then the work done, is W equals to Q into potential at point A minus potential at point B. Okay, so this is a very simple expressions also. You already know. So here, so this is the case. This is the case. Here we calculate the work done in terms of potential, right? But if we calculate this work done in terms of electric field, then what can I do actually? Okay. So work done. So work done calculations in terms of electric field. Okay, so we already know what we know actually. So we know there are relations between electric field and potential is nothing but electric field and potential is nothing but V equals to minus integrations minus infinity to R E dot dr. Okay, E dot dr. And this is the first case. The first case is when charge is moving from infinity to finite point R, is the first case. Or the second case is the potential is equals to minus infinity A to B E dot dr. This is the second case. Okay, so we use these expressions for the calculations of work done here. So now the work done, so now the work done when a charge is moved point A to B is W minus Q, okay, A to B E dot dr. Okay, so this is the final expressions when electric field given and we want to calculate the work done against electrostatic force. Okay, when a charge q is moving from a point to b point and we want to calculate the work done against electrostatic force, so this expression is very important. ठीक है, तो अगर आपके पास इलेक्ट्रिक फील्ड गिवन है और आपको एक पॉइंट चार्ज को क्या करना है, एक्चुअली पॉइंट चार्ज को आपको ए पॉइंट से बी पॉइंट तक मूव कराना है against the electrostatic force and you want to calculate the work done, or then what you do. Okay, so this is the expressions actually. So this is the expressions for single charge. Now we move to calculate the work done or potential energy from a system of charges. Okay, from a system of charges. So let us take a heading, calculate the work done or potential energy okay, to a system of charges. To a system of charges. Okay, to a system of charges. What we do actually? What we do? If we consider, we have three charges. Okay, first of all, we take a simple case actually. Let us consider we have three charges. Okay, q1, q2 and q3. Okay, and we take charges. We take charge q1 from infinity. This is the situations. Okay, we just so work done. This is the situations. So the situations is like that. You take charge q1 from infinity. So when a charge q1 is take from infinity, so no work done, because at that point there was no charge. Okay, there was no charge. So let us consider you have a three charge. Okay, you have a three charge. A system, there are three charge q1, q2 and q3. Okay, and this all charges, this is a system. Now we take a separate case actually for understanding purpose. Let us take a separate case for understanding purpose. So let us consider the charge, okay, q1 from infinity. Let us consider take the charge. One point is very important, take the charge. Okay, take the charge q1 from infinity. So then what happened? Then no work is done. Why no work is done? Because here's basically the case is like that. This is the infinity point and I take the charge that point, that is q1. Okay, so but that case there is no work done is happen. There is no work is done. Why? Because at that point, okay, because at that point there is no charge. That's why no, as at that point there is no charge, so electric field is 0. So as electric field is 0, okay, electric field is 0, so work done also should be 0, right? So that is the main reasons. So basically, in simple way, if I say a charge from infinity to take a point, and that point there was no charge. If that point have no charge, so in that no charge, so electric field also 0. So if the electric field is 0, work done is also 0. Okay, so work done is there is no work done, because at that point electric field is 0. Okay, due to lack of presence charges at that point. Okay, this is the very simple case. So the first case, W1 is equals to 0. Now take charge Q2 to that point from infinity. Okay, from infinity. Now take this charge Q2. Now take this charge Q2 from infinity, but the distance between these two charge, is R12. Okay, this is the second case actually. This is the second case. So then what happened actually? So now take charge Q2 to that point. Take charge Q2 from infinity at a point that is distance between charge Q1 and Q2 is R12. Okay, then work done. What is the work done? Then work done, W2 is equals to the charge Q2 into potential due to the first charge, due to the charge Q1. Okay, so potential due to charge Q1 at the locations of Q2 actually. So you have to remember, this is the potential due to charge Q1 at the locations of charge Q2. Okay, so now that is equals to Q2. Q1 is potential is Q1 upon 4 pi epsilon naught R12. Okay, so this is the equation number 1. Now take charge Q3 from the infinity to that point. So now what is the case is actually, now take this third case. Okay, now take this third charge. Okay, now take this third charge. Okay, now take this third charge as like that. At that point we take Q3, and this Q3 charge is situated from this first charge is R13, and the second charge is at a distance R23. So now we calculate the work done to take this charge Q3 at that point from the infinity. Okay, now take charge Q3. Okay, so work done. So work done W3 is equals to Q3 potential due to charge 1 plus Q3 potential due to charge 2. Okay, so Q3 that is equals to Q1 4 pi epsilon naught R13 plus Q3 into Q2 upon 4 pi epsilon naught R23. So this is the very simple case we here perform. So in this way we are calculate the electrostatics energy is basically. Okay, so we calculate here the work done. So now the total work done to assemble the system, work done to assemble the system each W equals to W1 plus W2 plus W3. So that is equals to W1 is equals to 0. Okay, that is 0 because when charge Q1 is take from infinity to point, at that point there is no charge. Okay, so now W2 is equals to Q1 Q2 upon 4 pi epsilon naught R12 plus Q1 Q3 upon 4 pi epsilon naught R13 plus Q2 Q3 upon 4 pi epsilon naught R23. So for that system, okay, for that system we are calculate the net work done. So the work done to assemble the system will store as the potential energy of the system. Okay, so here take a very good important point, take a note. This is very important. The note is the work done, okay, the work done to assemble the system will store, that is important, will store as the potential energy. Okay, will store as the potential energy of the system. Okay, as a system. So this is a very good questions. Or when you discuss the important point or important concept, then please focus on the concept part. Okay, because concept is very important for your learning step. So now we want to write here the generalized expressions for in charge. Okay,
So the generalized expressions for n charges. Okay, for n charges. Suppose we have a system of n charge, then work done is equals to 1 upon 4 pi epsilon naught summation over I 1 to n summation over j 1 to n qi qj upon rij, where please remember j is greater than 1, greater than I. Okay, j is greater than 1, obviously. Okay, but there is a pair for I and j. Okay, so to ignore this, मतलब यहाँ पे क्या हो रहा है देखो, एक सिंपल मैं बता रहा हूँ. ठीक है, मान लो तुमने क्या किया, ए Q1 है, Q2 है, तो तुमने वर्क डन कैलकुलेट किया. या फिर ऐसा हो सकता है ना, 1 अपॉन 4 पाई एप्सिलॉन नॉट Q1 Q2 अपॉन R12 और W इक्वल्स टू 4 पाई एप्सिलॉन नॉट Q1 Q2 अपॉन R21. ऐसे भी हो सकता है ना, सेम ही तो है. मतलब Rij और Rji सेम वैल्यू देखो, इस दोनों का वैल्यू बेसिकली सेम मिल रहा है. तो इस प्रॉब्लम को रिजॉल्व करने के लिए मतलब 2 बार तुम कॉम्बिनेशन ले सकते हो. इस मिस्टेक को अवॉइड करने के लिए, ठीक है, इस मिस्टेक को अवॉइड करने के लिए मतलब क्या करने वाले, इसको लिखने वाले द करेक्ट एक्सप्रेशंस. एक्चुअली लिखते हैं द करेक्ट एक्सप्रेशंस, about to avoid the pair, to avoid the pair into is. Okay, work done W is equals to half into 1 by 4 pi epsilon naught I 1 to n j 1 to n qi qj upon rij, and here I not equals to j, here I not equals to j. So the expressions is 1 upon 8 pi epsilon naught I 1 to n j 1 to n qi qj on rij I not equals to j. So this is the exact expressions of work done. Okay, this is the exact expressions of work done. So this is the formula. So this formula is actually applicable only for point charge. Please remember, this formula is actually applicable for point charge, not applicable for continuous charge. Be careful. Okay, so from this formula we can find the energy of the system directly. Okay, you take some notes here. The notes is the formula is valid or applicable for only point charges okay, and from this formula, now use this formula we can find energy of the system directly. Okay, this is a good point. Energy of the system directly. Okay, so let's take an problems to understand the concept in better way. So let us take an example or problems. So question 1, there is a triangle. Okay, there is a triangle. This is a triangle. So each side a length A, each side have a length A. Okay, and the charges at the corner is plus Q and plus Q. Calculate the energy of these configurations. What do you calculate? Calculate the energy of these configurations. Okay, calculate the energy of these configurations. So we take the very basic case actually. So this is the question 1 and question 2. Okay, let's take another question to another for second question. First of all, we calculate the energy of the configurations. So already you was discussed how to deal this type of problems. You just pick in your own way Q1, Q2 and Q3. Oh, you already know when you take the charge Q1 from infinity, then there is no work done, right? Then there is no work done. So here W1 equals to 0. W2 is nothing but Q1 or Q2. Okay, मान लेते this is the charge 1, this is the charge 2 and this is the charge 3. Okay, so Q into Q2 into V1. Okay, so Q2 is nothing but Q, but V1 is also Q1 upon 4 pi epsilon naught A. So it is nothing but Q square upon 4 pi epsilon naught A. And for the charge W3 is equals to basically Q3 V1 plus Q3 V2, right? So Q3 is Q, V1 is Q upon 4 pi epsilon naught A, Q into Q upon 4 pi epsilon naught A. So it is nothing but Q square 4 pi epsilon naught A. This is basically 2Q. That is basically 2Q square upon 4 pi epsilon naught A. So the energy of these configurations, energy of these configurations is W equals to W1 plus W2 plus W3. So that is equals to Q square upon 4 pi epsilon naught A. W1 already we know that is 0 and W3 is equals to 2Q square upon 4 pi epsilon naught A. So it's equals to 3Q square upon 4 pi epsilon naught A. So this is the energy of the configurations. Okay, so this is the energy of this configuration. So I think it is very good questions. Okay, and let's take another problems. Let's discuss the question number 2, that is asked in TIFR 2012. Okay, here the question is three charges. Okay, the three charges Q are successively brought from infinity, okay, and each placed at the one of the three vertices of the equilateral triangle, okay, and assuming the rest of the universe as a whole be neutral, okay, and the energy E naught of the electrostatics field will increase successively. Yes, that is obvious. So now, and that is E0 plus delta 1, E0 plus delta 1 plus delta 2, and E0 plus delta 1 plus delta 2 plus delta 3. So what is the questions? Question is, okay, find out the ratio of delta 1 plus delta 2 plus delta 3. Okay, so how can I calculate? First of all, we already know, so that equilateral triangle, okay, and let us take each equilateral triangle has side A, and first of all we take charge, that is 1, 2 and 3, charge Q from infinity, take charge from Q infinity. So from that case, work done is 0. Okay, work done is 0. So as work done is 0, so here the delta 1 is nothing but delta 1, and delta 1 plus delta 2 is, or all are the basically here the work done. Okay, all are basically here the work done, right? So for that case, so from when the charge Q take from infinity to 0.1, then we get work done W1, that is nothing but delta 1, it's equals to 0. And when the charge Q take from infinity to 0.2, then work done W2, that is equals to delta 2 is equals to it's nothing but Q square upon 4 pi epsilon naught A. We had already discussed that. And when charge Q, again this charge Q take from infinity to 0.3, then you get work done W3, that is equals to, that is nothing but delta 3 is equals to that is equals to basically 2 Q square upon 4 pi epsilon naught A. In the previous questions we was already discussed how we get this work done in step by step. So now it's time to calculate the ratio of delta 1, delta 2, delta 3. So delta 1 is to delta 2 is to delta 3, that is equals to 0 Q square upon 4 pi epsilon naught A, that is equals to 2Q square upon 4 pi epsilon naught A. So it is nothing but 0, 1:2. So option D is the correct answer for these questions. Okay, so I think ये वाला क्वेश्चंस तुम लोगों का क्लियर हुआ है, ठीक है? सो इसी तरह इनको प्रॉब्लम्स को आगे हम लोग लेके जाएंगे. तो प्रॉब्लम को समझना इम्पोर्टेंट है, प्रॉब्लम का बेसिक जो है उसको समझना इम्पोर्टेंट है. अगर तुम एक एक प्रॉब्लम का बेसिक तुमको समझ आ जाएगा ना, तो आगे जाके प्रॉब्लम्स को अच्छे से डील भी कर पाओगे, ठीक है? आगे जाके तुम प्रॉब्लम को डील भी कर पाओगे. सो ओके, let us take another problems. So let us take another problems actually. So question number 3, suppose there is a rectangle, okay, suppose square, not rectangle, this is a square. Each side have side A. Okay, okay, okay. Each side have length A. So basically, three churches are situated at the corners of a square of side A. Okay, three churches are situated at the corner. So that is minus Q, that is corner 1, corner 2, and that is corner 3. So three charges, that is corner 1 plus Q, corner 2 minus Q, corner 3 minus Q. These three charges are actually situated at the square, the corner of the square. So how much work done required? So how much work done required to bring a fourth charge plus Q to place at the fourth corner. ओके, सो एक्चुअली क्या करना है, तुमको इन्फिनिटी से लेके एक चार्ज को इस फोर्थ कॉर्नर में प्लस क्यू चार्ज को तुमको प्लेस करना है. तो उसके लिए कितना वर्क डन तुमको करना होगा? तो इस कॉर्नर में तुमको चार्ज लेके आना है और कैलकुलेट करना है वर्क डन. तो इसके लिए क्या करना होगा, जो बाकी तीन चार्ज है, कॉर्नर 1, कॉर्नर 2 और कॉर्नर 3, इसके लिए तुमको कॉर्नर 4 में तुमको पहले पोटेंशियल कैलकुलेट करना होगा, नेट पोटेंशियल कैलकुलेट करना होगा, है ना. और इस नेट पोटेंशियल को तुमको क्या करना है, इस नेट पोटेंशियल को तुमको जस्ट मल्टीप्लाई करना है Q प्लस Q के साथ, एंड देन यू कैन गेट द रिजल्ट for this work done. So it is a very simple questions, this type of questions many time asked in your exam. Okay, many time asked in your exams. So first of all, work done required. So work done required टू असेंबल द सिस्टम. तो जो सिस्टम तुमने एक फॉर्म करना चाह रहे हो, इसके लिए कितना वर्क डन चाहिए, बस यही तो कैलकुलेट करना है तुमको, है ना. यही तो कैलकुलेट करना है, राइट. ओके, तो उसके लिए वी ऑलरेडी नो द फॉर्मूला, राइट. वी आर ऑलरेडी नो द फॉर्मूला. सो फॉर्मूला इज नथिंग बट, क्या है फार्मूला, वर्क डन टू assemble the system W equals to 1 by 8 pi epsilon naught summation over I1 to n J1 to n Qi Qj और आई जे, बट आई नॉट इक्वल्स टू जे. यहाँ पे तुम देखो, तुम्हारे पास 4 चार्जेस है, तो आई का इनका लिमिट कितना होने वाला है हमारे पास पता है ना. तो W इक्वल्स टू 1 by 8 pi epsilon नॉट. सो फर्स्ट ऑफ ऑल हम लोग 1 और 2 के बीच का जो कॉम्बिनेशन है वो हम लोग करेंगे. सो Q1 Q2 upon A plus Q1 Q3 upon A plus Q1 Q4 upon the distance is nothing but root 2A, right. So that is equals to root 2A. So this is the combinations for Q1 plus Q2 Q1 upon A plus Q2 Q3 Q2 Q3 root 2A plus Q2 Q4 upon A. Okay, next case is for Q3. So Q3 Q1 upon A, Q3 Q2 upon root 2A, Q3 Q4 upon A. So this is the case. Okay, so for we actually calculate net work done, actually calculate for these configurations. Okay, another case is Q4 Q1 is equals to root 2A, Q4 Q3 upon A plus Q4 Q2 upon A. So now we just calculate the Q1, Q2 and Q3 and Q4. So that is equals to 1 by 8 pi epsilon naught minus Q square upon A minus Q square upon A plus Q square upon root 2A minus Q square upon A plus Q square upon root 2A minus Q square upon A minus Q square upon A plus Q square upon root 2A minus Q square upon A, Q square upon A plus Q square upon root 2A minus Q square upon A minus Q square upon A. So that is equals to 1 by 8 pi epsilon naught minus 8 Q square upon A plus 4 Q square upon root 2A. Okay, so that is equals to Q square upon 8 pi epsilon naught, that is equals to 8 pi epsilon naught A, 8 minus 8 plus 4 by root 2. Okay, so that is equals to, if I take common 2 or 4, we take common 4, so 4 Q square upon 8 pi epsilon naught A minus 2 plus 1 by root 2. So okay, that is equals to Q square upon 2 pi epsilon naught A minus 2 plus root 2 minus 2 plus root 2. So that is the result of those questions. So in this way you can calculate the how much work done is required to bring the fourth charge at fourth charge plus Q at the fourth corner. ठीक है, तो मैंने बताया था तुमको अगर इस तरह का प्रॉब्लम डील करना है तो इस वे में तुम सॉल्व कर सकते हो. ठीक है, तो आई थिंक इट इज़ वेरी इजी to solve this kind of problems actually. Okay, so देखो आज के जो क्लास में हम लोग एक सिस्टम ऑफ चार्ज के लिए ये वाला प्रॉब्लम मैंने हम लोगों ने डील किया है ना. सिस्टम ऑफ चार्ज के लिए हम लोगों ने प्रॉब्लम को डील किया. तो नेक्स्ट लेक्चर्स में हम लोग देखेंगे एनर्जी का जो फॉर्म होता है, एनर्जी कैलकुलेशंस का. इस एनर्जी कैलकुलेशंस के बारे में देखेंगे फॉर कंटिन्यूअस चार्ज. अभी तो आज के क्लास में हम लोग डिस्क्रीट चार्ज के लिए कैसे इलेक्ट्रोस्टैटिक्स एनर्जी कैलकुलेट करना है, कैसे वर्क डन कैलकुलेट करना है, ये सारी चीज़ हम लोगों ने देखा। ठीक है, तो कल की क्लास में हम लोग मतलब नेक्स्ट दिन के क्लास में हम लोग इसका कंटिन्यूअस चार्ज डिस्ट्रीब्यूशंस के लिए भी इसका कैलकुलेशंस क्या होगा, कैसे हम लोग इस तरह का प्रॉब्लम को डील करेंगे, ये हम लोग देखेंगे। ओके, तो चलिए आज के लिए क्लास इतना तक है। कल के वीडियो में हम लोग और भी इसके ऊपर थोड़ा बहुत डिस्कशंस करेंगे। ठीक है, क्योंकि IIT जैम का एग्ज़ाम बहुत ही नज़दीक है, तो हम लोगों को क्लास को कंटिन्यू करना होगा जितना IIT जैम के लिए इम्पॉर्टेंट है। ठीक है, IIT जैम के लिए इम्पॉर्टेंट है, तो उसी के ऊपर हम लोग थोड़ा बहुत फोकस करेंगे। ठीक है, IIT जैम और TIFR और जेस्ट का जो कॉन्सेप्ट है, ठीक है, तो इसी कॉन्सेप्ट के ऊपर हम लोग पूरा डिस्कशंस करेंगे। इससे ऊपर ज़्यादा डिस्कशन नहीं करेंगे हम लोग, CSIR नेट के लिए डिस्कशन करने वाला नहीं है। जस्ट हम लोग IIT जैम के पर्पस से हम लोग इसको थोड़ा बहुत स्टडी करेंगे। ठीक, तो IIT जैम का एग्ज़ाम इम्पोर्टेंट है क्योंकि हम लोगों का फोकस IIT जैम के लिए है। ओके, ठीक है, तो नेक्स्ट वीडियो में हम लोग IIT जैम का जो प्रीवियस ईयर का क्वेश्चन है वो भी डिस्कशंस करेंगे, तब जाके तुम लोगों को थोड़ा बहुत आइडिया हो जाएगा। हाँ, ऐसे IIT जैम का क्वेश्चन में इसी पर्टिकुलर टॉपिक से क्या क्या क्वेश्चन एक्चुअली पूछा है ना। तो हम लोग फोकस हम लोगों का एकदम ये वाला कोर्स ओनली फॉर IIT जैम के लिए है, IIT जैम जस्ट। ओके, IIT जैम जस्ट और TIFR के लिए ही है, तो इससे अब तो थोड़ा बहुत तुम लोगों का हेल्प हो जाए, बस यही है। और जो लोग इस चैनल में न्यू है प्लीज़ सब्सक्राइब करिए और चैनल को सब्सक्राइब करके शेयर भी करिए। हाँ, इसमें हम लोग जस्ट पूरा एकदम टू द पॉइंट कंटेंट के ऊपर हम लोग फोकस करेंगे। इधर उधर का बात हम लोग करने वाला नहीं है। जो प्रॉब्लम बात करेंगे, प्रॉब्लम्स एकदम PYQ के बेस्ट होगा। PYQ से जैसे क्वेश्चन पूछता है उसी के फॉर्म में हम लोग थ्योरी को धीरे धीरे हम लोग बिल्डअप करेंगे, तभी जाके हम लोगों का प्रिपरेशन थोड़ा बहुत अच्छा होगा। राइट, चलिए बात करते हैं नेक्स्ट लेक्चर में।